Hello, everyone. I'm Guy Patrick with GeoEnviroPro. We offer online talks and training for environmental professionals, and we're dedicated to helping you and your colleagues stay in touch with current science and gain knowledge to help you succeed. Today, I'd like to introduce you to a new online course we're offering. It's called Contaminated Sites Fundamentals, Investigation, Risk Assessment, Remediation. This is a comprehensive 13-week course designed for those that are relatively new to the field of environmental site assessment and remediation. Or maybe you're looking to brush up on your skill set, or maybe you're a senior scientist, but you recognize the need for practical training for your staff. This course is for all of you. We begin on April 6th, meeting once a week until June 28th. We're going to be covering a full range of themes and topics that are foundational to the practice of site assessment and remediation. Some of these themes include the process and science behind site contamination, contaminant transport and attenuation, practical approaches and tools for sampling soil, groundwater, and soil vapor, the fundamentals of human health and ecological risk assessment, and finally, the identification and selection of effective site remediation technologies. We have a team of instructors who have years, as a matter of fact, decades of practical experience in consulting and in the regulatory community. Let's hear some clips from what these people have to say about this course.
So in this course, we're going to cover a number of concepts. One of the key ones is the conceptual site model. And this is probably the most important concept. All projects should start with the CSM, as I show in that lower right photo, because you want to understand the site before you even start the investigation. You want to design the investigation around your understanding of the site, and you also want to try to identify whether there are any potential, sort of immediate potential health concerns or environmental impact concerns, and then proceed through the investigation. The best way to develop these conceptual site models are through teamwork. Bring together the team, all the experts, all the field staff, bring the knowledge together, draw out your understanding of the site on the whiteboard. You can also use some tools like the conceptual site model builder that is showing on the lower left. And then once you've done all of that, you may end up with something like this. This is a conceptual site model showing the contaminant sources, the stratigraphy, and also pathways for contamination to migrate, and the receptors. And that'll guide the whole process of site investigation and remediation.
We're going to move into contamination basics. We're going to be covering the nature of contamination. How does it get from the source above ground into the source below ground? And what are the processes that act on that contamination? What are the chemical properties that give this stuff the ability to either get into soil vapor, get into a breathing space, dissolve into ground? And what happens once it's in the subsurface? How does it migrate? What are the processes involved? What are the attenuation processes involved? Natural or induced attenuation processes? We're going to be focusing on certain types of sources such as L-NAPLs and D-NAPLs. What do these terms mean? What is some of the lingo and jargon that people use in the business here to characterize these liquids, and why are they a problem? And what do we do about them? And then finally, as we define transport pathways towards receptors, what are the processes that get this contamination to the receptor? What is the surface water, groundwater interaction, for example, that could pose ecological risk, or vapor transport into a house to pose human health risk? We're going to have exercises, case studies. We're going to talk a bit about chemistry. Not a lot, but see this molecule in the bottom there? 2,3,7,8 tetrachlorodioxin, a real nasty one. We'll actually give you some simple key ideas of how to look at something like that and know whether you're dealing with a 1, 2, 3 trinasty or something pretty benign. When we talk about NAPLs, we're going to be showing things like this video clip. You look at the timeline here, obviously this is speeded up, but it's literally, this is a video clip that put together by an environmental engineer with Burns McDonald in the States, who were kind enough to let me use this and share it with others. They just set up a little experiment to see how fast does this napple go through the subsurface and what happens. There's a whole pile of processes involved here that we'll be covering in the course. Look forward to having you join us there and discuss these things. We're going to talk about soil contamination, the importance of scale, regional scale, local scale, and within jar sample variability. What does that mean? How does that affect the way we acquire samples?
So in Module 3, we are going to pivot from the technical and regulatory world and discuss the business of consulting. Is it a business? Are we here to solve a problem or make money or both? I used to work with somebody who used to say that being an environmental consultant was a lot like being a dentist, and that nobody actually wants to come to you, they have to. So in this module, we're going to teach you how to do the job well and hopefully how to make things a little less painful for your clients. So we're going to cover the basics of consulting and project management, like developing scopes and budgets, scheduling, deliverables, and invoicing. But we're also going to cover the finer points, like understanding and meeting your clients' needs, adding value to your projects and for your clients, helping your clients navigate and understand the contaminated sites process, client communications, like delivering good and, more importantly, delivering bad news, tips to ensure repeat business from your clients. And then lastly, we'll share some of the secrets that we've learned from consulting business, which we kind of did the math before this presentation and realized we have over 150 years collectively of consulting experience. So I think we have a tidbit or two to share with you. So this is a really important module. This isn't the kind of stuff that you learn in an earth sciences or an environmental engineering program, but it really can be the foundation for a successful career in consulting.
How do we actually collect our samples? And we will go into the various different media: soil, groundwater, soil vapor, sediment, and surface water. And as folks may know, definitely a lot of varieties of ways to collect samples. For soil, for example, drilling and test pitting, even just drilling, there's a variety of different methods, and there's a different case to be made for each of them depending on the different site. So in this module, we'll go through some of the pros and cons of each. But not only that, we'll go into the actual practical aspects. How do they actually work? And this is quite dear to my heart because when I first started in environmental consulting, I was trying to plan for going to the field by trying to find videos and clips on YouTube, pictures. And to be honest, there just really isn't a lot out there. What we've done here is we've taken a lot of photos. I've gone to Van Mars' drilling yard to take some clips, and we're going to be walking through those to give folks on the course a really good understanding of what actually is out there without having to wait for various projects to come up so that they can get that training experience. Here's in the slide is just some like really high level snapshot of some of the photos that we have available for a variety of different sampling methods.
So for this module, we have solicited the support of a local practitioner who's a bit of a phase one guru. She's been doing pretty much nothing but phase ones for over 20 years. So she is going to go over the different types of phase ones, the CSA standards for phase ones, the types of historic information that are reviewed and why when information is gathered from them, how to conduct site investigations or site visits, how to conduct interviews, and then how to tie all of that information together to identify areas of potential environmental concern and to develop recommendations for next steps. She's also going to do a really cool exercise, which is going to, I understand, use Google Earth to plunk people down into the middle of a site and get them to do their own site investigation. So it should be pretty fun. And then building on the phase one module, we're going to talk about phase twos. We are going to cover a lot of material in this module. We're going to talk about how to build on the phase one recommendations to design a sampling investigation plan, different types of investigation methods. So kind of touch back on what Zara is going to talk about module 4. Data validation and QA/QC, selection and application of standards, data interpretation. So this is how to see the forest for the trees and to understand what you're really dealing with, similar to Guy's Beyond Data course. And then how to identify your areas of concern and your contaminants of concern and make recommendations for the next steps of investigation if warranted. So similar to the module 4 on field investigations module, this module literally packs like years worth of field investigation into one module. So I think it'll be very valuable to people.
2 Mondays in June, I'm going to be presenting on the fundamentals of human health and ecological risk assessment. What is contaminated sites risk assessment, you ask? Well, it's a systematic process that we use to define and quantify potential adverse health effects to humans, plants, and animals from exposure to environmental chemicals currently and in the future. And what we use it for in our industry is to determine the need for and the nature of risk management measures at contaminated sites.
This is how you close out a site. Theoretically, this is the end point to the cycle. And we'll talk on key issues in remedy selection. So that's both contaminant properties and the context, as well as the remedial objectives. You're going to find us drawing back on the conceptual site model, which underlies pretty much every single module we've talked about. We'll talk about the commercially available technologies, as well as emerging technologies. Talk about advantages, disadvantages, a lot of horror stories, a lot of case studies and what went wrong so you can avoid those faux pas. I got 60,000 cubic meters in a biopile right now that we're having major difficulties with. You don't have to make that mistake. We'll talk about how to get detailed design information. This format isn't enough to give you the math, but I can show you where to get the math. And we'll talk about how you contract this, how you actually tender these projects, how you get them delivered, owner role, consultant role, contractor role. We'll talk about not alternatives to remediation, but kind of long-term management approaches that help you come to a cost-effective closure, which could involve isolating portions of the site or removing the hotspots. And we'll talk about applications of monitored natural attenuation. One of the things that we see a lot is a synergy between risk assessment, monitored natural attenuation, and remediation, where the most efficient and sustainable allocation of societal resources is removing some critically hazardous material, risk managing the rest, and allowing natural systems to recover.